And go.
Hey everybody, I'm Myron Ferguson. I'm here at the Habitat for Humanity House in Glens Falls, New York. I'm about to do the blower door test, which is required in order to get our certificate of occupancy. What we're trying to figure out by doing the blower door test is how many air exchanges per hour we have under a negative 50 pressure, and that number is supposed to be 3 in order for us to meet the building code, energy code here in upstate New York. 3 is actually a pretty tight number. It's not super easy to accomplish. That is probably better than 90% of the homes would actually have if I were to do a reading. But this being a Habitat for Humanity house, we try to keep things as far as insulation and air sealing simple. But we still need to achieve this. It doesn't matter. We still need to achieve that number. So what we've done here, because of climate zone 6, we were required to put a thermal break on the outside of the house. So we have a 1 inch of foam on the outside of the house. Our walls are 2x6. They're insulated with an R21 insulation. The outside of the house is very well sealed. We taped all the seams and we foamed and caulked as much as we could out there. Inside the wall cavities, before we insulated, we actually foamed and caulked inside those wall cavities. And then we actually caulked every seam in the wood framing, like along the top plate and around the windows. And then around every electrical outlet and light switch, we isolated them as well. We put a special box around them to isolate them. So no air from inside the structure is going to enter those wall cavities. And we hope to accomplish the same thing from the outside. In the basement, around the rim joist areas, we put 3 inches of closed cell foam. And all the basement walls are insulated very well as also. On the ceilings, this is a vented attic. What we did was we hung the drywall first, and then we air sealed everything in the attic. We crawled around up in the attic where we can easily see all the little holes. Any place we can see light coming through, we foamed and caulked. And then we blew in 15 inches of cellulose insulation. So these are all products that were easy to find, easy to use, and all the caulking and foaming were also quite easy to do and very inexpensive. So now comes the test. All that hard work, does it pay off? So I'm going to turn on the blower door. What we have is a fan stuck in the doorway, and we have a gauge up here that does all the calibrations and measuring for me. What I'm going to do is I'm just going to turn it on. There's a bunch of numbers I have to push, so bear with me. And once it's stable, I'm just going to press enter. Now how this works is, I have this fan on. When I turn it on, it's going to depressurize the house. So it's going to be sucking air out of the house. So what we're trying to achieve is a negative 50 pascals. So I'm going to be looking at that number, see if it's negative 50, and then a number on the other side here tells me how many cubic feet per minute we're exhausting at that negative 50 pressure. So before I turn it on, I have to remove these rings. So first I'm going to remove all of them. So the fan is totally open. This is something, when it's totally open, that usually is something that you would want for a very leaky house. But let's just do a quick test. Right away it's telling me a low reading, which means I have to put another ring back on. I've already tried this test today, so I know that I need to put 2 of the rings back on. So I'm going to reconfigure this so that both rings are attached and just the center ring is out. Okay, now I start it up again. Bring it down to negative 50. Okay, so at a negative 50, I have a CFM of about 430. I knew, ahead of time I calculated out, my goal would have to be a 900 or less. If I hit 900, I knew I was going to pass at the number 3 air exchanges per hour that we're looking for. But we actually came up with 430. So this is CFM under a negative 50. I calculated that out to the actual air changes per hour under negative 50 pascals, and that comes out to 1.4. Remember, our goal was 3. So we're less than half of what we had to be. So we've easily accomplished, we surpassed the goal of a 3. If another interesting number that I like to tell people is, how many air exchanges are we having per hour under natural conditions without the blower door attached? And in this particular house, I calculated that out to be 0.09 air changes per hour under natural conditions, which is a very low number. I've been in many houses that is well over 1 air exchange per hour under natural conditions. Those houses would be very difficult to heat, and all that air coming in and out of the house through all these unknown places is not necessarily a really healthy home to live in either. So what we need to do now is, because this house is so airtight, a air exchange system is required. We have one installed in this house. It's very simple. What we have is we have 3 exhaust fans that are on switches that are going to come on periodically to exhaust air. And the replacement air is not going to come in through all the little cracks in the foundation, any place we didn't seal. Is coming in through 3 ports that we've installed. So we have a balanced system that was very easy to install. And that will be set to 120 CFMs. So those fans are going to actually be exhausting that much air continuously around the clock. But keep in mind, that's our only air exchange in the whole house. We have almost nothing coming through naturally. So that's going to provide a very healthy home. This home is going to be very easy to heat, and it's going to be very comfortable. So that's the reason for this energy code requirement. It helps us ensure to the customer that we're building a very healthy, easy to maintain, and inexpensively to heat home. I've already done the blower door test, and I know what I need to set my air exchange system to. In this house, we're using the fans, the exhaust fans, to exhaust the air. We have fresh air ports bringing the fresh air in. But in here, for example, we have the kitchen range, and we have a fan up in the ceiling. I have 2 bathroom fans. And what I really want to know is, when I turn this on, what is the CFM? I mean, I think when I purchased this fan, it's supposed to be like 180 CFM. The bathroom fans might be 60. But that number isn't necessarily true because we have the elbows and the length of the pipe and all that. So I want to get an accurate reading of what the CFM that this fan will be exhausting. And what I have here is an exhaust fan flow meter that this just goes over the top of that pipe. I push it in nice and tight, and I have a door opening that I've already set for the estimated CFMs of that fan. And this is hooked to my pressure gauge. So what I'm going to do is I'm going to turn the fan on, push this against the ceiling, and my pressure gauge will tell me the actual CFMs of this fan. I'm pushing it up nice and tight. And the gauge is pretty stable at 176 CFMs. So this fan is exhausting 176 CFMs. So that's really good to know. Now I can use these numbers that I get from each fan to help me decide how long these fans need to run periodically throughout the day to reach the desired exhaust for this house.